This will be a brief review of speed. There's not much to it, honestly. There's this formula. V is equal to d over t. So V is the velocity is equal to distance divided by time, or displacement divided by time. That's really all there is to this formula. That's all there is to this whole unit. In essence, the complications lay in the details, but this is the only formula you have. Now, you can manipulate this formula a little bit to solve for distance. So if we multiply both sides by t, we would end up with distance is equal to velocity times time. And then, if we divide by velocity in this equation, we can get time by itself, and time is equal to distance over velocity. So in short, you have three equations that you can use. Okay? Now, like I said, the complications arise from other things. So let's talk about some of the graphs where complications can arise. All right. Actually, let's pause real quick and talk about the difference, the technical difference between velocity and speed. Now, I told you that 99% of the time, you're going to be able to talk about velocity and speed interchangeably. But for this particular unit, you need to make sure you know the distinction that velocity is displacement over time and speed is distance over time. And since displacement is a vector, velocity needs a direction. Okay? Make sure your velocities have a direction. Alright? Now, V, confusingly, is used for both speed and velocity. Most of the time when it's equal to velocity, you will see that over it, little arrow over it. But not always, and so that is a tad bit confusing. Just trust me on this. If it's asking you to distinguish the difference between velocity and speed, you must know this right here. And that's the only time you need to know the difference, honestly, is whenever this shows up right here. All right, let's talk about some graphs. All right, if we have a displacement and time graph here, then if we have a straight line, that slope is the instantaneous velocity of any point on it. Oops, let's just pretend I wrote that down here. Alright, so the instantaneous velocity of any point on it. Alright? But if we have a different line, you have to find a different slope. So the instantaneous velocity here is different than the instantaneous velocity here. Okay? You would have to do two different calculations to find those things. So whatever line segment the point is on is the instantaneous velocity for that line. Let's ask this. If this is a displacement versus time graph, then how far did this object travel? Let's say that this is 1 meter and this is 4 meters, all right? Well, he went from 0 to 4 meters, right? So his displacement was 4 meters, positive, and then in the second line segment from here to here, he went 3 meters because he went from 4 to 1. So he went 3 meters, and displacement is negative. But remember, distance isn't concerned with positive or negative. So his displacement for our graph here would be equal to 1 meter, but his distance would be the total amount traveled. So 4 plus 3, which would be 7 meters. All right? So that's using the graph of displacement versus time. What about velocity versus time? What if we have a graph that looks like this? With velocity going this way, then this way, then this way. And then let's just say, for argument's sake, that it drops below the line. Okay? And I'm just going to give these some arbitrary numbers just so we got something to work with. Alright. What if I want to know this object's total distance traveled? If I want to know its total distance traveled, I have to find the area under the curve. So for total distance, that's the area under the curve, or rather the area between the line and x-axis. So for this, if I want to know the total distance, I would have to do this area and this area. Okay, that would give me the total distance traveled. But what if I wanted the total displacement? How far from the start is this guy? Let me get back here. Total displacement. Well, then I would need to do something different. I would need to find the distance traveled above the line, okay, and then the distance traveled below the line. And those two numbers will probably be, they may be different, they may not be different, but what you're going to have to do is to subtract them. So for displacement, you subtract above the line, the area above the line minus the area below the line. It's supposed to be an A there. Alright, so area above the line minus area below the line. Alright, and that's how you would find the total displacement. What if you wanted to know the instantaneous velocity at any point here? Well, let's just say that this is 50 meters per second. You just, if I ask you what it is at 6, you just find 6, go up 6, and then look over 50 meters per second. The instantaneous velocity at 6 is 50 meters per second. Alright? So that's the basics behind speed. The problems, as I'm sure you are aware from our homework assignment, are more complicated than this. They most certainly are. So if you have a question on a specific problem, if you'll shoot me a tweet or an email, I will try to answer that, okay? I will try to do it on this and post it. Alright? So hopefully this helps you out with learning about speed. I will do vectors next.